In 12.3, we're going to be talking about two-way tables. So what are we going to be learning about those two-way tables? You're going to be learning how to make them, how to find their relative and conditional relative frequencies, and using those conditional relative frequencies to find conditional probabilities. I'm not going to lie, this can get confusing. Alright, so we're going to start by making a two-way table. Now here's the good news. Making a two-way table is fairly easy, but it's understanding it that can be a little more difficult. So making a two-way table. So what is a two-way table? A two-way table is a frequency table, which tells you how many times something occurs, that displays data collected from one source that belongs to two different categories. One category of data is represented by rows, and the other is represented by columns. So, here's an example. Suppose you randomly surveyed freshmen and sophomores about whether they are attending a school concert. The two-way table is one way to organize your results. Here it is. Attendance and class would be your two different categories, and each category has two different things. So attendance is either attending or not, class is freshman or sophomore. Each entry, this is important because we're going to be doing a lot of the same type of vocab. Each of these entries are called joint frequencies. Now, the sum of these rows and columns are called marginal frequencies. So marginal would be adding together the freshmen and then those attending and not attending, and also adding together sophomores. Those are the marginal frequencies. And let me slide that up there. But you can see at the bottom, the joint frequencies, that's all four of those numbers are the joint frequencies. Example 1. In another survey similar to the one above, 106 juniors and 114 seniors responded. Of those, 42 juniors and 77 seniors plan on attending. Organize these results in a two-way table. Then find and interpret the marginal frequencies. So, you would first start off by drawing attendance, your categories, and you could separate that into attending and not attending. And this could be class. And we're talking about juniors and seniors. Now we want the total of both ways. Whoops, that's not where I wanted to put that. So we know that 42 of the 106 juniors are attending. So 42 of the 106. We know that 77 seniors plan on attending of 114. So to get not attending, you just subtract 64, 37, and now the totals. 119, 101, and the total, which is 220. Now it says to find and interpret the marginal frequencies. Now the marginal frequencies, let's quickly go over this. These four numbers are the joint frequencies. These are the marginal frequencies. They're the totals. So we have to interpret them. So I'm going to actually pop up a much better example. And here we go. This is interpreting each of those numbers. So you have to tell me what it means. 119 students are attending. 101 students are not attending. 106 juniors responded. 114 seniors responded. And 220 represents the total number of people surveyed. That's interpreting the marginal frequencies. Now, finding relative and conditional relative frequencies. You can display values in a two-way table as frequency, like you did in the first example, or as relative frequencies. This gets difficult of keeping it all straight. There's relative frequencies or joint frequencies, marginal frequencies, and there's also joint relative frequencies, marginal relative frequencies, and conditional relative frequencies. A joint relative frequency is the ratio of a frequency that is not in the total row or total column to the total number of values or observations. A marginal relative frequency is the sum of all the joint relative frequencies in a row or column. A conditional relative frequency is the ratio of the joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or a column total of a two-way table, which leads into this. Study tip. Two-way tables can display relative frequencies based on the total number of observations, the row totals, or the column totals. This is confusing, I'm not going to lie. It's not hard, it's just confusing about what it all means. So let's start with joint and marginal relative frequencies. We're going to use the survey results from example 1 to make a two-way table. So I'm going to bring in example 1. And we're going to show the joint and marginal relative frequencies. So we're going to take what we know. So there we go. So what we have to do is look at what joint relative is. It's the ratio of the frequency that is not in the total row or total column. So not total row, total column. So we're not doing 119, 101, 106, or 114. Basically, it's the total of everything. So the junior would be 42 divided by 220. All you're doing is dividing each of these by 220. 77 divided by 220. 64 divided by 220. 37 divided by 220, but we're giving them as decimals. So this, I'm going to bring up a better picture here, but we're going to divide everything by 220 because that gives us our decimal values. So 0.191, 0.291, and so on. We take each of these joint frequencies, divide it by 220 because that's not in rows or columns, and that gives us our joint relative frequency. Now the marginal frequencies are taking the sum of our joint relative frequencies. So we add 0.191 and 0.35, we get 0.541. We take 0.291 plus 0.168, we get this. We add together the rows as well. Now the total of everything should be 1. Why is it 1? Because that represents 100% of everything surveyed. Now the conditional is taking example 1's data again. So here it is. And we are going to use the survey results to make a two-way table that shows the conditional relative frequencies. Now if we look back at our definition, it is the ratio of the joint relative frequency to the marginal relative frequency. So let's say that again. The ratio of the joint relative frequency to the marginal relative frequency. Well, we already have the data we want, so I'm actually going to bring that back up. So here it is. So to do the conditional relative frequency, notice what we do. We take juniors, which is 0.191, and we divide it by the row. Now notice it says row. If it said column, we would use 0.541 here. But it says row. So we're going to take 0.191 and 0.291 and divide it by our row total, which is 0.482. And that gives us these percents. The senior, we're going to take 0.35 and 0.168 and divide it by 0.518. And now notice we don't have totals here. We don't need those. So what does this say? Given that a student is a senior, the conditional relative frequency that he or she is not attending the concert is about 32.4%. So example 4. You can use conditional relative frequencies to find conditional probabilities. Example 4. A satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results, given as joint relative frequencies, are shown in the two-way table. Notice, joint relative frequencies are just these. They have not added these together to get the marginal relative frequencies. So A, what is the probability that a randomly selected customer who is located in Glendale will recommend the provider? So what do we want? We don't just want yes. We want the probability of yes, given that they are from Glendale. Using our chart, what we learned back last chapter, we're going to take the probability that someone picked what? Glendale and yes, divided by the probability of who's in Glendale. So what's the probability that someone picked Glendale and yes? It's right here, 29%. So that'd be 0.29. The probability of Glendale, now people in Glendale are both of these, 0.29 and 0.05. So if we divide that, this gives us approximately, whoa, that's really bad. Approximately let's do a percent. 85.3%. B, we want the probability that randomly selected customer will not recommend the provider is located in Long Beach. Now notice what it says here. In A, it said located in Glendale. That's why Glendale was on the bottom. It didn't say located in any city. So we don't need to add up everything. We just want Glendale. So now part B. What is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? Notice this is different. The first one says Glendale would recommend the provider. Now we want to know anyone who will not recommend, but is from Long Beach. So we're going to actually first need to know what? The probability of Long Beach, given first that they select no. So we want to know, this is first, not recommend the provider. That's who's first. Then from there, we see if they're from Long Beach. So the probability, what do we want? We want no and from Long Beach. So we look at our chart. No and from Long Beach is 0.04. Divided by this. Of everyone who picks no, we look at who picks no first. So everyone that picks no would be adding up 0.05 plus 0.03 plus 0.04. That gives us 8, 12. So it would be 0.04 divided by 0.12, which is 1/3, which is approximately 33.33%. Lastly, the probability determine. It's not probability. The third one asks, determine whether recommending the provider to a friend and living in Long Beach are independent events. So what is the probability of living in Long Beach? Well, first, the probability of Long Beach is just 0.32 plus 0.04, which is 0.36, okay? Now we want to know Long Beach and whether they'd recommend the provider. So we want recommend the provider. So probability of Long Beach given, that's a yes. Using our formula, we know that means it's a probability of yes and Long Beach divided by the probability of yes. So the probability of yes and Long Beach. So yes and Long Beach, if we look at our chart, is 0.32 divided by, yes, well, we add up all of our yeses, 0.29 plus 0.27. That gives us 0.88. If you divided that, you get approximately 0.36. So, because they're equal, 0.36, 0.36, these two events are independent. So you would say, yes, they are independent. And I know this is confusing. It can get tricky. I get that. But we're not done yet. In example 5, here we go. And the good news is this is our last example. A jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. The table shows his findings. Which route should he use? Well, let's start by making our chart. So here's our chart. We have result and route, whether or not he reached his goal, did not, and ABC. So we want, what do we want here? We want the joint relative and marginal relative frequencies. So remember what we have to do. We have to divide each of these joint frequencies by the total. So the total, which is not here, but the total up here. So not any of the totals of rows or columns, but the total of everything that we've surveyed. So I will tell you that if you add all these together, you get a total of 55. So let me move that there. All right, so in A, it looks like we have 11. Route A reaches goal. That's 11. 11 divided by 55, 0.22. Then we take 6 divided by 55, which does not meet goal of route A. That is 0.12. Then B, and we continue that. So this is 0.22, 0.24, 24%, 8%, 12%. Now to get the marginal relative frequency, we just add them up. So this gives us 0.68, 0.32. That gives us a total of 1 for 100%. And here's our totals. So I now put all of our answers up here. We have to figure out the actual conditional probabilities. So you divide each joint relative frequency, because remember, I want to know, does he reach his goal? But first he has to run route A, and so on with route B and C. So I have to divide the joint relative frequency by the marginal relative frequency in each row. So, and I believe it says, yeah, so by each row. So here's how you do it. You take 0.22, he reached his goal, 0.22, 0.24, these are all these, and you divide them by their row. So divided by 0.34, divided by 0.3, divided by 0.36. These are the percents. So which path should he take? He should choose route B. It gives him the highest percent at about 73%. Here's your vocabulary from this section.